So here we have a line graph, and we need to work out how many degrees warmer was it at 3 p.m. than at 3 a.m. So we find 3 p.m. We can draw a line up and across. So the temperature at 3 p.m. was 2 degrees, and now we can find 3 a.m. The temperature was minus 5 degrees. So we need to find the difference in temperature between 2 degrees and minus 5 degrees. And as in this graph, each line or each square is 1 degree, we can simply count the difference. So 1, 2, 3, 4, 5, 6, 7 degrees is our answer. At 6 p.m. the temperature was 4 degrees lower than at 3 p.m. What was the temperature at 6 p.m? Well, we need to find the temperature at 3 p.m. and that was 2 degrees. And now it was 4 degrees lower, so we need to count back 4 from 2. So 1, 2, 3, 4. The temperature at 6 p.m. was minus 2 degrees. This chart shows the population of Cornwall from 1950 to 2010. In which year did the population first reach 400,000? So we need to find 400,000 population. We read across, then we go down, and I'm making sure to draw these lines as straight as possible. I'm not drawing them like that or like that. I'm drawing a line straight down, and I can see the year is about halfway between 1970 and 1980, so I would say the year would be 1975. How much did the population increase from 1950 to 2000? So we need to find the population in 1950, which is about 300, slightly under or about 350,000. And then we need to find the population in 2000, which is 500,000. We need to work out the difference, so we need to do 500,000 minus 350,000, which gives us 150,000. So the population increased by 150,000 in those years. What was the population of Cornwall in 2010? So we find 2010, we draw a line up and then across, and we can see the population is between 500,000 and 600,000. Now I'd say the line is about a quarter of the way up from 500,000, and so it's a quarter of another 100,000, so it's another 25,000. So I would estimate the population in 2010 would be about 525,000. This graph shows how the temperature changed in Liam's room one afternoon. Estimate the temperature at 3:15 p.m. Now we don't have 3:15 p.m. labelled on our time axis, but we can work it out because between each hour there's 1, 2, 3, 4 squares or 4 lines. So each of those lines must be a quarter of an hour, and a quarter of an hour, a quarter of 60 minutes is 15 minutes. So 3:15 is going to be 15 minutes after 3 o'clock, so we're looking here. And we need to estimate the temperature. So let's draw a line up from 3:15 and then a line across. And now we need to read this scale here. So we have temperature labelled between each 5 degrees of temperature, there's 5 lines, so each of these lines is 1 degree, so 20, 21. It's between 22 and 23, so I would estimate the temperature at 22.5 degrees. Estimate the time when the temperature was highest. Now the temperature's highest point is here, so we can draw a line straight down, and then we need to read the scale carefully. Now that's 2 o'clock, and remember each line was 15 minutes, so 2:15, 2:30. It's between 2:45 and 3 o'clock, but I would say it's slightly closer to 2:45. So I'd estimate it's about 2:50. How much did the temperature change from 2 p.m. to 2:30 p.m.? Give your answer to the nearest degree. So we need to find the temperature at 2 p.m., which is just a touch under 17 degrees. Then we need to find the temperature at 2:30, so halfway between 2 p.m. and 3 p.m, which is just under 22 degrees. And now we need to find the difference, so 22 minus 17 is 5, so the temperature changed by 5 degrees. Alfie and his brother walked from home to their school. Their school is 2 kilometers from home. The graph shows information about Alfie's journey. How does the graph show that Alfie walked at a constant speed for all of his journey? Well, it shows a straight line, which means a constant speed because he covered the distance in a gradual amount of time. It's a straight line, so it's a constant speed. Alfie's brother left home 10 minutes before Alfie. He arrived at school 20 minutes after Alfie. He walked at a constant speed as well for all of his journey. At what time did Alfie overtake his brother? So we need to draw a line for Alfie's brother. And he left home 10 minutes before, so he left home at 7:50 because Alfie left at 8 o'clock. He arrived 20 minutes after, so Alfie arrived, if we read down, at 8:30, which means Alfie's brother must have arrived 20 minutes later, so at 8:50, and they're both walking to school, so they're both walking 2 kilometers. Now we need to join up the points on our line. And then the point where the lines cross is the point where Alfie has overtaken his brother. So if we look at where they cross, we read down, we can see the time, if we go down, is 8:10. So Alfie overtook his brother at 8:10. "500 children started a 20-kilometer sponsored cycle ride. The graph shows how far they cycled. At what distance were exactly half of the children still cycling?" So we have the number of children over here. 500 started, so we need to divide 500 by 2 to find half of 500. That's 250. And we can see 250 is going to be halfway between 200 and 300. And then because we need to find the distance, we need to go along from 250. Then we need to go down. Now this question's quite difficult because the distance isn't labelled here. And now some children might think, well, it's 3 after 10, it's going to be 13 kilometres. But we need to think more carefully. Between 0 and 10, we have 1, 2, 3, 4, 5 squares or 5 lines. And 10 divided by 5 is 2. So each square counts for 2 kilometres. So we can count up 2, 4, 6, 8, 10, 12, 14, 16. So half of the children were still cycling at 16 kilometres. Estimate how many children completed the 20-kilometre cycle ride. So we go up from 20 kilometres and then we go across, and we can see that it's between 150 and 200 children, but perhaps it's slightly closer to 200. So rather than the middle of 150 and 200, let's go for a number just slightly closer to 200, so perhaps 180 children. This graph shows the outside temperature from 4 p.m. to 10 p.m. on a day in winter. At what time was the temperature -2 degrees? So we need to find -2 degrees. We go along, then we go up, and we can see that it was -2 halfway or between 8 o'clock and 9 o'clock. Now, because there's 2 squares between each hour, each square must be half an hour, so each square must be 30 minutes. So this is between 8:30 and 9 o'clock. And I'd say it's about halfway between 8:30 and 9 o'clock. So I would say the time when it reached -2 would be 8:45. How many degrees did the temperature drop from 5 p.m. to 7 p.m? So let's find the temperature at 5 p.m. It was 2 degrees. Let's find the temperature at 7 p.m. It was -1 degrees. So then the difference in temperature, the drop, was 1, 2, 3 degrees. The graph shows the average height of girls in the UK from age 6 to 11 years. Emily is 1.38 metres tall. She is the average height for her age. How old is she? So this question's difficult because we're given the height in metres, but we need to change it to a height in centimetres so that we can read the graph. Now we change metres to centimetres by multiplying by 100. So Emily is 138 centimetres tall. So we need to find 138. Well, we can see that they're going up in 5s, and there's 5 lines between each of these lines here. So if we count on 135, 136, 137, 138 is this line here. And then because she's average height, and this graph is showing the average height, we can go down. And we can see that Emily is exactly 10 years old. Now Zoe is 9.5 years old. She's also 1.38 metres or 138 centimetres tall. How much taller than average is she? Well, we need to find what the average height for a 9.5-year-old is. So we need to find 9.5 on our graph. Now there are 1, 2, 3, 4 lines between each year. So half of 4 is 2, so we need to go 2 lines on from 9. There's 9.5, there's halfway between 9 and 10. So the average height for a 9.5-year-old is 135, but she is 138. So if we find the difference, 138 minus 135 is 3 centimeters. Kirsty measured the length of her shadow every hour on one sunny day. She plotted her results on this graph. Estimate the length of Kirsty's shadow at 3:30. So each of these squares is 1 hour. So 3:30 is 3:30. That's going to be between 3 o'clock. It's going to be in the middle of 3 o'clock and 4 o'clock. Now what you could do with questions like this is join the line up. But I'm not going to join the line up. I'm just going to estimate where the line would be. So 3:30, so halfway between 3 and 4. If we go up, I would imagine the line would be about here. So then I can carefully read across. And we need to find the length of the shadow. We've not got the length very clearly labelled here. So we need to find out what each of these squares represents in length. Now there are 1, 2, 3, 4, 5 squares to get to 100. So 100 divided by 5 is 20. Each of these squares is 20. So we could count 20, 40, 60, 80, 100, 120, and we can see the line is between 120 and 140. So I would estimate the length of the shadow is about 130 centimeters. Now estimate a time when her shadow was 180 centimeters long. So we need to find 180. So remember, each square is 20, we've worked out. So 100, 120, 140, 160, 180 is going to be here. And if we were to connect those points, if we were to join up a line, I guess it would cross the line about here. And then if we move down, we can see that it crosses halfway between 9 o'clock and 10 o'clock. So my estimate for when the shadow was 180 would be 9:30. This graph shows the distance Alfie and Chen walked in an afternoon. They started at 1:45 and had 2 breaks. How many kilometers did they walk between the first and second breaks? Now the breaks are going to be the times when they didn't travel any further distance. So they're going to be these 2 horizontal lines. Now this first horizontal line, this first break, is when they were at 6 kilometers. And the second horizontal point is when they were at 10. So we need to find how many they walked between the first and second. So we need the difference between 6 and 10, which is 4 kilometers. At what time did Alfie and Chen start their second break? So the second break would be the second time that the line went horizontal. The start of the second break would be when it started to go horizontal. So we can draw a line straight down. Now we need to be careful. We need to think, how is this line graph labelled, well, between every hour there are 1, 2, 3, 4 lines. So each line across is a quarter of an hour, or 15 minutes. So they started their second break at 4:15, or 4:15.